All right, everyone, welcome to lesson 42. This is slope fields, and this is pretty much a secondary lesson to the separation of variables that we saw earlier, which is the y with dy, x with dx. So that's kind of just a secondary lesson to that. And all right, you guys are going to like this lesson. It's kind of cool. With that being said, last class, everyone should have gotten a packet from me with lesson 41, and on the back side of that was lesson 42 notes. Now you do need to fill these packets in, but I should get you started, okay? So we're going to fill these notes in. All right, so what is a slope field? It's just a graphical representation of slopes that represent your general solution. Well, what does that mean? Well, a lot of the times it's just a limited graphical area, and it's just a bunch of different slopes that are plotted on here. So let me show you how it works. So here's an example of a differential equation, and we know that because this is a derivative, dy dx equals y over x. So if we have to sketch the slope field for this differential equation, what we want to do here is plug in integer values for x and y that are basically, in this case, around the origin. And this would represent the different slopes. So let's talk about the different points that we have, okay? I'm going to start by writing all these points out. So let's start with the origin 0, 0. If I plug in 0, 0 into this function, that would just give me 0 over 0, which is in fact undefined. And what kind of line is undefined? Well, undefined is really a vertical line, right? And that's how we get an undefined slope, okay? Let's make this a little bit thicker here. There we go. Okay, so that's how I would sketch an undefined line, or better said, an undefined slope. So a little segment of that line right there at that point. Because not all the points are going to look exactly the same, you see? Now I'm going to do some other points on here. So let's go with this one, 1, 0. Okay, if I plug in 1, 0 into this function, 0 over 1 is what I would get, which is really just going to give me 0. So what does that look like? Well, a slope of 0 looks like that. Horizontal, right? And what if I were to plug in negative 1 and 0, right? Well, that's going to be 0 over negative 1, also a slope of 0. Okay, now let's get into the stuff that's not, well, actually, we have a couple more zeros. Let's do these two up here. This is 0, 1. All right, so if I plug that in, I'm basically going to get 1 over 0, another undefined. So that would basically come from a vertical line right there. And this point right here is 0, negative 1, right? 0, negative 1, if I plug it in, negative 1 over 0, another undefined slope, which basically means comes from a vertical line. Okay, let's do the rest of them here. If we had to sketch the slope for this point here, this is the point 1, 1, which when I divide 1 divided by 1, what is that slope going to be? It's just going to be 1. Hey, what does that look like? Well, it looks like if I'm connecting this point with this point, and that's a slope of 1, rise 1, run 1, and that pretty much just looks like this. Okay, let's do the rest of the points. We got negative 1 and positive 1, and so if I divide them, negative 1 is what we get, right? So what does that look like? Well, it looks like I'm connecting this point with this point because we go down 1 and 1 to the right. So that just kind of looks like a slope like this. Okay, so you have some of the different layouts of all the different slopes here. I don't know how helpful that's actually going to be for you. Maybe it'll help you. Okay, let's look at this point. This is 1, negative 1. Right, and if we divide them, we actually just get negative 1. So again, just a negative slope right there. And then negative 1 over negative 1, this is going to give us positive 1. So we end up with a positive slope right here. Okay, that's how we would sketch a slope field. Overall, not too bad. If we had to create a slope field and show the approximate solution that passes through a given point, our first step is to actually sketch the slope field. So got a lot of points here, right? Okay, so let's see. If I plug in 0, 0, 0 plus 0, well, that's just going to be 0. So that's going to give me this kind of line. Okay, next, let's plug in this one. This is 1, comma 0. Well, when I add them up, 1 plus 0 is 1. That's just a slope of 1, but I just need to draw a little segment of it like this. Okay, this is 2, comma 0. So 2 plus 0 is 2. And what does that look like? Well, it looks like this point gets connected, rise 2, run 1, something around here. Well, that's a little bit steeper, no? So it's just kind of going to look something like that. Okay, and then we're going to do the rest of them, I guess, on the x-axis. This is -1 plus 0, and we end up with a slope of -1. And then over here, -2 plus 0 is -2, and that's just this point basically connecting with this point, and a little bit steeper then, right? So you can kind of see where this is going, all right? So that's pretty much how that works, all right? You guys fill this in, and then pause the video, and then we'll come back. Okay, so this is what our slope field looks like after we sketched it, right? Well, in this case, we had to create a slope field, and we also had to show the approximate solution that passes through a given point. So we haven't done that yet, right? So this is the point 1, 1. So here's 1, 1. That's this point right over here, right? And I noticed that this almost looks like a wave, right? It's almost like a like something that's kind of pulling this point up, right? And that's exactly right. Something is pulling this point up, right? So as you sketch this, yeah, make sure that you do in fact pull it all the way up. Where is it pulling from? Well, it looks like it's pulling from this line right here. So it's actually going to be like a little bit of a curve like that. And then it almost looks like this is a wave that's pulling it down and kind of curving up, right? So if I had to sketch this, I want to make sure to kind of sketch it as this is like some sort of a horizontal tangent, a turning point, if you will, right? And then we're going to bounce off of that point and kind of go all the way through, right? Now, sometimes students like to go from the left border all the way to the right border, right? And in past FRQs, it's something that they really look for. But anything like this would be pretty accurate, okay? This has come out as a common FRQ question before. You'll see one in a moment when I show it to you, but this function would represent something that's concave up. All right, remember that if your function is concave up, that represents that our tangent line, just like this, is below the curve. And if we had to make some sort of an estimate, we would say that that estimate is an underestimate. Okay, whereas if your function is concave down, our tangent line would be above the curve, and therefore we would have an overestimate. Okay, so let's take a look at some FRQs. I wrote here could be 8 out of 9 points because we're really not too sure if something like this is going to come out on this year's FRQ. The answer booklet is supposed to be totally blank. And if that's the case, well, then really the slope field part wouldn't be sketchable, if you will. So where would the 9th point come from? And that's what I would love to know. You guys are going to have to get back to me and tell me. But anyway, let's start, okay? How can we sketch this slope field? So we know how to sketch the slope field because we know that we can plug in all these points, right? If we plug in 0, 0, that's just 0 times 0 and divided by 2, and that's 0 right there, right? Okay, if I plug in 1, 0, multiply those two numbers together, you get 0. Again, over 2 is just going to be 0. And then over here, same thing, right? -1 times 0 is 0. Okay, so that's going to give me that slope there of 0. Let's plug in this one now, 0, 1. Again, 0 times 1 is going to be 0, so over 2. Okay, another 0 there. Probably another 0 here because 0 times 2 is still 0. Okay, there we go. So we really just have to do these things here. And 1, 1, if we multiply 1 times 1, we're going to get 1 and then 1/2. So what does that look like? Well, it's just rise 1 and run 2, or go down 1 and run 2 this way. Okay, so a little bit more slanted than the other ones, okay? And then over here, this is 1 times 2, which is in fact 2. 2 divided by 2 is 1. So we're going to put a slope like that. Okay, let's do this one. -1 times 1 is -1. So -1/2 looks like this. And then this is going to be -2 over 2, which is just -1. So this is what our slope field would look like. Okay, now the rest of these questions, believe it or not, we've actually done. So the rest of this FRQ, piece of cake. All right, let's write an equation for the tangent line that goes through the point 1, 1. Hey, how do we do that? Well, this is really just doing y minus y1 equals m times x minus x1. And the cool thing here is, well, we already know the slope. The slope is given to us right there in the question, except all we got to do here is plug in 1, 1. We kind of did that already, but 1 times 1 is just 1, 1/2 is what we end up with, right? Okay, awesome. So that's going to be our slope. We already know the point is 1, 1, so y minus 1 equals 1/2 x minus 1. And then this is an equation. This is going to be 1 point right there, okay? The other point comes from the estimate. So how can I make this estimate? Well, I'm going to plug in 1.2 right there, and then I'll just add the 1 to the other side. So this is going to be 1/2 1.2 minus 1, and then this 1 here, I just want to bounce it to the other side, so that's going to be plus 1, and I don't even have to simplify. Believe it or not, this right here, this gets you the second point, or let's just say this was 1 point. Arguably then, this would get you the third point on that FRQ, okay? So we've actually already done this. You guys should feel pretty comfortable doing this stuff. Okay, so if this function is concave up, then we know it looks like this, right? And we know that our tangent line then has to be below the curve. So is this estimate that we just made, is it an overestimate or an underestimate? Let's explain this, because if you don't explain it, you don't get the credit, right? Okay, hopefully everybody's thinking the same thing as me. We're thinking that this is an underestimate, but let's explain why. All right, so we would say that f of 1.2 is an underestimate, and we can write because f of x is concave up, so the tangent line is below the curve. Okay, so I'm going to write all that now. Okay, so once again, f of 1.2 would be an underestimate because the tangent line is below the curve. You could mention that the function is concave up, not really necessary here. Okay, let's take a look at the next, oh, by the way, point systems. Let's talk about that. This would be 1 point right there. So point number 4. Okay, and then that means that this is the money maker here. Remember, FRQs are worth 9 points. So this guy is going to break down those last 5 points. Okay, let's talk about where we get them from. Find the particular solution. I'm missing something here. The particular solution is always going to say y equals f of x to the differential equation with the initial condition of 1, 1. This is when we do y with dy and x with dx. So I'm going to actually divide y to both sides so that I get 1 over y dy, and if I multiply dx to both sides, I really just end up with 1/2 x and then dx. So I need to separate the variables. That's the first step. If you separate the variables successfully, you get the first point. Okay. The next step is, can you actually integrate these things? All right. And if you integrate them correctly, well, then you'll probably get the second point. Okay. This is going to be ln of y, which is equals to, and then we're power ruling this guy, right? So this is x squared over 2, but there's already a 2 here, so it becomes x squared over 4, and we'll just do here plus c. All right, so now I integrated this side and I integrated this side. So you know what that means, actually. Believe it or not, depending on how they break down the points, they'll probably give you a point for each integral, each side of these integrals, okay? So that's actually kind of nice. So 3 points already there, okay? Remember, we're only missing 2 more, okay? So, all right, where do we get the c from? Well, we get the c from this initial value. So I like to do it on the side, and I like to just plug in. This really just means 1, 1, right? So if I plug this in to what I have so far, this is ln of 1 equals, well, 1 squared. That's 1 over 4. And then plus c. All right, let's see, ln of 1, that's a 0, and we end up with 1/4 plus c. Let's move 1/4 to the other side. So negative 1/4 is equals to c. All righty, so that gets plugged in now. So plugging in your c value, believe it or not, that is point number 4. This has to be done in order for you to get all the points, okay? So this is point number 4. Point number 5 is going to come from, hey, do you know how to isolate y? Well, we're going to just exponentiate both sides of this equation here. Remember, there's no need to simplify anything on FRQs. And so we can leave it as e to the power of x squared over 4 minus 1/4. If you're afraid the reader isn't going to know that this is an exponent, just put it in parentheses. Okay, all right, so that's our answer there, y equals f of x. That's our function, in other words, and that should be point number 5, okay? So that's the breakdown of the points, okay? Now this packet here for the lesson 42 notes has a lot of examples, lots of FRQs, okay? You can see here there's another one of these slope fields, another question like the one that we just did. Okay, I'm not going to do this one. You guys can try this one on your own. Very, very similar. All right, a little bit of Riemann sums there. And okay, this is something that I do want to talk about. All right, so in this one here, it says consider the differential equation, and we start off with this nasty guy right there. By the way, this was an FRQ in 2006. So you can see that these are pretty common. They haven't really gone anywhere. The scoring of the guideline, this kind of changed a little bit since 2006, but I mean, it's almost 20 years since that exam, so that makes sense, okay? You can see part A just asked for sketching of the slope field. That year, they did 2 points for that, okay? Anyway, I'm going to skip the sketching of the slope field. I feel like everybody's kind of got that. There is a horizontal line with the equation of y equals c that satisfies the differential equation. Find the value of c. So once you're done sketching, I want you guys to try this. Once you're done sketching the slope field, right, you'll look for the horizontal line, okay? Now, if you guys were able to try it, hopefully you did, this is what the slope field looks like. Do you guys see this horizontal line right here? This is the horizontal line y equals 1. In other words, c equals 1. All right? And when they graded this FRQ, they graded it as 2 points for part A and 1 point for part B. If the students came up with that horizontal line, c equals to 1 there, or even y equals to 1, well, then they gave them that first point. So the third point there. So that was actually pretty generous, okay? Anyway, that's what the slope field should look like to check your work. It's actually in your packets, so feel free to check it, okay? And then the part C of that question, I think I have a typo because I meant to put like part C and then part D over here. So I meant to split them. But anyway, particular solution on this one, which by the way would require some U substitution. Okay, so let's do this one just because it's fun. Find the particular solution here of this differential equation. Well, first off, I want to get this guy with the dy. Okay, and I want to get the dx to the other side. So I'm going to divide y minus 1 squared on both sides. All right, so I'm going to really end up with 1 over y minus 1 squared dy equals, and I'll multiply dx to both sides now, and I just end up with cosine of pi x dx. All right, so because I have this screams to me U substitution, and because I have this over here, this also screams U substitution. So this is a whole lot of fun. All right, so let's try to do the U substitution. So let's change colors here. If we say that U is going to equals to y minus 1, then when we do du, we really just end up with 1 and then dy. Okay, so perfect. I can swap this out easily. This will be 1 over u squared. And if I'm going to integrate now on both sides, 1 over u squared, maybe it's easier to move that u to the top, right? U to the power of negative 2. All right, I'm going to put here du equals, and now I'll do the other side, right? So I don't want to use another u because I feel like we've already used u. Maybe we want to use another letter, like let's try to use v this time, okay? So let's put v equals to like pi x, all right? Remember, pi is just a constant. So if we take dv instead of du, we're going to get pi, and then that of course is dx. So isolating dx, well, that just gives me dv over pi. I'm going to take that pi out of there, so it's 1 over pi, okay? And so we end up with, let's see here, let's take 1 over pi out of there. Rewrite our integral. This is going to become cosine of u, and then dv. Oh, not u. We said v. dv. There we go. Okay. All right, so we're ready to go. We're ready to do our integrals. So here's just the power rule. So this is going to become u to the power of negative 1 over negative 1, which is equals to, over here, this is 1 over pi. All right, let's multiply by, this is going to give us sine of v, right? And then plus c at the end there, right? Okay, so, whew, that was fun. Okay, so remember, we still need to plug in our initial condition, which we have. Okay, our initial condition was 1, 0. Okay, now when you plug in your initial condition, you're plugging it in as x and y, and we were using u and v, so we're all tangled up here. Let's rewrite this stuff into terms of x and y, and then we can plug that in, right? Okay, so this u, I want to move it down to the bottom, so it becomes just regular u to the power of 1. I guess I'll put my negative 1 up here, and then equals, this is 1 over pi. I'm going to go back and swap out my v, which is v we said was pi x. So this is really going to become times sine of pi x, okay? And then plus c, right? Okay, so what was u? Let's swap that out. I'm just going to use the eraser here. Okay, we said that u was the same as y minus 1. So let me just replace it, y minus 1. Bingo. Okay, now it's time for that initial condition. So remember, I like to do that on the side because sometimes, like this, it can get kind of messy. All right, so negative 1 over, I'm plugging in 0, 0 minus 1, that's just negative 1, equals, and we have this 1 over pi that we're going to multiply by, okay, let's see, x is 1, 1 times pi is still pi, and sine of pi is just going to be 0, all right? So plus c there. So this ends up giving me 0, right? It's all going to cancel right there. And I'm just left with c equals to 1. Perfect. Nice and easy, right? So we end up with negative 1 over y minus 1 equals to sine, maybe an easier way to write this, sine of pi x over pi, and then that's plus 1. All right, so if we want to try to get y by itself, maybe we can try to multiply y minus 1 to both sides, right? Get rid of that. But then that means I need to take this whole side and multiply it by y minus 1 as well. And remember, your goal is to isolate the y. So now we're going to work on getting this guy by itself. Okay, so, all right, let's rewrite what we have. Let's see, let's come over here. So we got negative 1 is equals to, all right, and then we have this, you know what I'm going to do? I'm going to put 1 over 1. I want to get a common denominator so that it's pi times pi right there. And so that I can just write it all as one fraction. I know this is probably overkill, but this is just a me thing. So we have sine of pi x plus pi, all of it over pi, and then we're multiplying it by y minus 1. Okay, so actually I'm glad that I did that because if I want to get this by itself, I probably want to divide by this, right? Or maybe I want to choose to multiply by the reciprocal. All right, if I'm multiplying by the reciprocal, I'm really just going to multiply by pi, which should cancel with this pi, and over sine of all of this, right, which should cancel that, which means if I do that to this side, I got to do it to this side. So now I'm going back to this left side, but I'm going to multiply it by pi over sine of pi x plus pi, there you go, right, and it still equals to y minus 1. Okay, and now I just need to add this 1 to both sides. There we go. And if you don't feel like rewriting it all over again, you can just go back here, rewrite it, and just put equals. Remember, we had y minus 1, so just put a plus 1 out here, okay? Because I know it's a lot to write, especially if you're low on time on those FRQs, okay? Anyway, so that right there, that's the breakdown. Now, how would these points be broken down? There's a lot of points to give here, right? They actually gave 6 on this one. So probably because of the u substitution on both sides. Okay. To be honest with you, I don't remember the exact breakdown of everything, but I know that this one was 6 points. I think we talked about this being 1 point there, the line, and then this other thing being 2 points. So that's 9 points in total. Okay, that was 2006. All right, we got one more lesson to go, everybody. Home stretch.